Hello, everyone, and welcome back to the Bear Necessities Workshop Hackathon series. Yesterday, we had Subquery. Today, we have Moonbeam. And this is a full-featured week, so we've got workshops just about every day. And I want to thank you so much for joining us. So as you may know, the Bear Necessities Hackathon encourages building with core pieces of Web3 infrastructure. That includes components, including Moonbeam, and it includes components such as indexers, gasless transaction providers, oracles, dexes, and as well as infrastructure providers like AWS. We're very lucky to have AWS as a sponsor, as well as several other sponsors. But even if you don't win a prize for the hackathon, you are eligible to apply for AWS credits, a very generous portion of these credits. And this is something that's very special because for builders, right, these credits are just as good as cash, and they help, of course, in your startup development journey. Now, without further ado, let me go ahead and share my slides and screen. And of course, there will be hands-on components as well. So if you've joined me for some of these connected contract workshops in the past, the beginning portions will feel a bit familiar, but we will have some different stuff as part of the demos and the like. And we're, of course, going to look at the bounties that we have for the actual hackathon so that you have information on what you might want to build. And feel free to ask any questions. Let me know if I'm going too fast, too slow, if there's anything that we could do differently. Very open to feedback. So yeah, today we'll talk about building connected contracts on Moonbeam. We'll look at precompiles. We'll look at general message passing and more. But we always start kind of from taking a step back and looking at the broader Web3 space itself and taking a look at kind of the a view of the entire ecosystem. So Moonbeam believes that the future is multi-chain. But if we kind of step back and ask ourselves, why is that? There are a ton of reasons. One is that it's increasingly easy to start up a new chain of your own. And when we say chain, it could be a layer 2, it could be a rollup, it could be a subnet, it could be a parachain, it could be a thread, it could be all these different things, right? And part of this is driven by the demand for block space. Part of this is driven by applications that may outgrow the layer 1 that they launch on and decide that they need their own layer 2, or they need their own app chain or their own parachain. You get the point. In this case, all of these chains tend to specialize in what they do best. And this is awesome. This is what Polkadot was founded on, was chains specializing in things that they do best. And this allows them to not have to make sacrifices or not have to make compromises. They can design the chain exactly as they'd like. They can have parameters and specific requirements or specific validator set, any type of specific setup that they'd like. And then, of course, Polkadot unites these blockchains together, as you know, through XCM and through a shared relay chain. And of course, Substrate makes it easy to launch a new parachain. And there are other ways that you can launch a chain as well. So as time goes on, we know that there are more and more chains that are going to be out there. And it's not something where you can put the genie back in the bottle or where you can really slow down this process at all. It's just the number of chains are growing and growing. But when we look at the ways in which we've sort of, the ecosystem has approached handling these different chains and deployments. The first approach, if you're a builder, right, the first and kind of the oldest approach has been you pick a chain and you go and deploy there. And you say to your users, we're here on XYZ chain, come find us. And that's your home base. That's where all of your code is. That's where hopefully your users come and they may need to bridge to you, right? It may be a new chain. And there are a couple advantages here, right? One is that you have one deployment. So you have one set of contracts to upgrade. You have one set of contracts to look at with your Open Zeppelin Defender in terms of monitoring funds and monitoring contract status and things like that. So it's simpler. But of course, there are downsides too. For one, you're limiting your audience. You're saying this is the only chain that we're going to be on. And some users, they may not know about that. They may not feel comfortable bridging, or it may just be a friction point of getting to you. So you're severely limiting your users. So then what team said was, well, we're EVM compatible and we can launch on a couple different chains. So let's do that. Let's copy and paste our original deployment and let's put it on a bunch of different chains. So we're now going to be deployed on several different chains and perhaps a layer 2 here and there. And we can kind of call this a multi-instance deployment. But of course, there are drawbacks in this case, right? It's important in this multi-instance deployment, or the original model of it, to know that these deployments, they don't know about each other. They're not connected. They're not sharing liquidity or benefiting from the existence of each other. It's not the case where if one chain is overloaded, they could just pass their users and liquidity to another one seamlessly. These are distinct walled gardens. And if you want to get to a new one, you have to switch your network and you have to get a new gas token and have a completely separate experience. Now, don't get me wrong. This is great for bringing new users on board, but of course, you're fragmenting them and you're fragmenting your liquidity, your concentration, all different sorts of things. And now, as a builder, right now you have 5, 6, 7, 8 different deployments to maintain, contracts to upgrade. This is a ton of work. This is overwhelming. So how can we solve this? What's a different approach that we could take? In order to introduce that, I first will touch a bit on Polkadot. And as I mentioned, Polkadot allows blockchains to specialize, right? Polkadot takes the approach, they're the best blockchains that are out there. There isn't one to rule them all. And the way that Polkadot supports these many different blockchains starts from its infrastructure and its architecture. And Polkadot's built with Substrate. And you can build your blockchain on Polkadot with Substrate as well. It makes it very modular to build your own chain. And it also takes away some of the complexities of lower level things, such as you don't have to deal with networking, and you don't have to deal with some low level infrastructure things related to blockchains. Instead, you can focus on building your chain, your apps, and your users. So Polkadot is this layer 0. It's a blockchain of blockchains, as you know. You don't launch your app directly on Polkadot unless you are building a whole blockchain. But you can launch a layer 1. And if you're launching an app, then you can choose a layer 1 on Polkadot to launch on top of. And Polkadot does a lot in terms of connecting these chains together. So I touched just upon XDM, which is a message format for these different chains to talk to one another. It's optional. It's opt-in. So a parachain can exist on Polkadot and say, you know what, I'm happy on my own. I just want to be here alone. That's unusual. Most chains want to connect with others, and certainly Moonbeam wants to connect with as many other parachains on Polkadot as we can to allow for the transfer of assets, to allow for remote contract calls, and much more, to allow for seamless interoperability. And the ultimate vision really is allow all of these chains to specialize in what they do best. With Moonbeam, it's connected contracts, and allow each chain to access the features of each other chain within Polkadot. And of course, the result of this is an ecosystem that's greater than just the sum of the parts. Polkadot is not meant to be a series of islands where the chains are each doing their own thing. And sure, they've got some scalability and they've got some shared architecture, but rather it's meant to be one that has that plus interoperability of these chains can call functions that are available on other chains that they wouldn't normally have. And not just that, but it allows them to take advantage of these features in a more efficient way, because that chain would be presumably doing it better because that's what it specializes in. And let's talk about where connected contracts come into the picture. So the idea behind connected contracts is that we have this multi-chain world, and we have this position where you want to interact with contracts on many different chains, right? And perhaps you're swapping a strange token pair. Perhaps you want to buy an NFT that's only available on one particular chain. Perhaps you're looking for information from an oracle, and that oracle is only available on one specific chain. Or, all of these could be different. With Moonbeam, you can access features and functionality on any different chain that's connected. And the list is huge. Not only can you access many other parachains within Polkadot, but you can also access ecosystems outside of Polkadot. That includes ones like Ethereum, Cosmos, and Avalanche. Hey, welcome, Lamont. Can you see everything okay? Let me know if you can't, and maybe just give it a refresh. So within Polkadot, XCM allows the communication between the different parachains, and then outside of Polkadot, we rely on general message passing providers such as Axelar, such as Layer 0, Hyperlane, Wormhole, and others. And this general message passing allows you to send messages between the chains. A message could be as simple, we'll see, as "Hello World." Typically, in a real world use case, that's not going to be the message that's sent, but rather the message that's sent is going to be something that holds contract data, right? If you're calling a contract on the chain that you're already on, right, you have to know the contract address that you want to interact with, and you have to know the payload that you want to provide, meaning you want to know the function that you want to call, and then any sort of parameters that function requires. And believe it or not, calling a contract on a remote chain is actually just about as simple as that. Now, of course, you need to know the destination chain that you want to interact with. You need to know the contract address that you want to interact with. You have to provide the payload. And then in some cases, you might, you typically always need to provide the gas for that transaction that's taking place on the destination chain, which simply means that you'll just send along a token payment with your transaction. And then the last part is just sometimes you may overpay for gas and you may choose to optionally provide a refund address, or other GMP providers may just say, don't worry about it. There's just, 10 cents left. Don't need to worry about that. I just wanted to mention also the several different ways that Moonbeam supports connected contracts. And this is a holistic approach. So you may be building a DApp on Moonbeam, and it may start as a single chain application. It may exist solely within Moonbeam, but after some period of time, you may look to go multi-chain and maybe approach that's more of a connected contracts approach. So let me just share a couple of the ways that Moonbeam enables this connected contracts approach. And one is, of course, having the connectivity through many general message passing providers. And the reason we have this thorough connectivity, it's not just one or two, but it's many, many GMP providers, is so that you have the optionality as a dev. You may say, I prefer XYZ GMP provider. You may say, I've already built a bunch of things with this specific provider. And so we don't want to be opinionated about which GMP providers to use. We want to give you all of them, and then you can choose and say which ones you want to pick and choose and build with. And in other cases, sometimes it's very good to have redundancy, to have a backup. There are applications in production on Moonbeam that use multiple GMP providers. And some of these have to do with nuances of each messaging provider. Some occasionally have maintenance windows or periods of small periods of downtime. And so it's important to have this sort of redundancy and backup. Of course, I'd be remiss if I didn't talk about Ethereum compatibility. Moonbeam started by bringing Ethereum compatibility to Polkadot. And not just EVM compatibility, but seamless Ethereum compatibility that's as close as possible to the developer experience on Ethereum. And we took that as far as bringing all of the different developer tools and integrations that you're used to working with on Ethereum. That includes Hardhat, Truffle, MetaMask. That includes the wallet experience. That includes unified accounts. So you don't have to use a Polkadot account in addition to an Ethereum style account when you're working with Moonbeam. You can use the same Ethereum style address, which is very, very important. And of course, finally, we support your team through all the different aspects of your growth, right? You may start as a DApp. You may become so big that you decide that you want your own parachain, or you may decide that you want your own parathread at some point. Due to the architecture of Moonbeam and the architecture of Polkadot, it's easy to transition and become your own app chain, so you can grow and you can scale. You're not locked in to the original setup that you choose. And of course, I've already spoken a little bit about general message passing. If anybody has any questions, feel free to drop them in the chat. But XCM is actually, the native GMP provider of Polkadot. And XCM, we won't go too much into depth, but XCM is just a language. It's a written format for writing messages, and you can really do anything with it. So in the terms of passing assets between different chains, there's a very specific format for how you construct an XCM message to communicate that, so that the receiving chain knows how to act on it. And the only other thing I wanted to mention here is that XCM is written to be generic enough that it could be used by other ecosystems and other chains outside of Polkadot, which I think is really cool. And it speaks to its flexibility and also the forward-looking nature. We're not trying to build walled gardens here. We're trying to build software that's open source and accessible and useful to all. So if there's another blockchain ecosystem that comes along and says, hey, we'd really like to use XCM as well, that is certainly an option. Cool. And let's take a quick look at kind of what are I mentioned kind of the single chain deployment model. I mentioned the multi-chain deployment model, but what do deployment models look like in terms of connected contracts? There are several, and here are just two quick examples, right? The big one here is the hub and spoke model. This is where the brains of your smart contract exist on Moonbeam. And then you have satellite smart contracts deployed to other chains. And they could be taking actions that are directed by the brains on Moonbeam. So you can have all of your complex logic. You can have your expensive contract deployments, so to speak, expensive in a gas usage term. So it's not going to be expensive in terms of fees on Moonbeam, but it may take up a decent amount of gas. You can have all that on Moonbeam, and then you can have logic deployed to other chains that's kind of auxiliary or supportive. And an example of that is Prime Protocol, which I can show you coming up in just a couple slides. And yeah, we'll touch on that just coming up right next. So hub and spoke, right? Each spoke is connected kind of in a one-off manner to the brains. And so you can pass messages, from the spokes to the hub to another spoke. That's certainly fine. And then the point-to-point model is a similar approach, but it's more focused on chains that are connected less in this one-to-many and more of like a one-to-one manner. But in both of these cases, this is an evolution, and an improvement, over the original multi-chain deployment model. So a quick example that we have for connected contracts here pertaining to Polkadot is with Lido. And so Lido has a liquid staking solution, of course, on Ethereum. They actually brought one to Polkadot and to Moonbeam specifically. So as you recall, you can't launch a smart contract on Polkadot, and Lido wanted to bring a liquid staking derivative for the staked dot product. And so you can't launch that on Polkadot, but you can launch it on Moonbeam. And it's made possible by XCM and also the ability to access XCM features through a precompile. And the way this works is it actually uses XCM in a couple different ways. So one is you have this you have a token called XC dot. XC dot is an XC20, which is just like an ERC20, but it's one that is transferable via XCM. So think of it just as a Polkadot native version of a ERC20, right? So you have your normal dot, and then you bring it to Moonbeam, and then it becomes XC dot. Once it's in Moonbeam, you can do anything you want with it. You can transfer it. You can use it in DeFi. You could do many, many things with it now that it exists as this ERC20 compatible asset. Another thing you can do is that you can stake it into Lido smart contracts. And in this case, Lido would use XCM to take that XC dot, transfer it back up to the relay chain, where it then exists as native dot, and then stake it to a validator and allow to earn staking rewards. And this is something that's all done autonomously. There is no trust factor built in. All of this is done programmatically in a single combined. I don't want to say atomic because it's taking place on two different chains here, but a single combined transaction. So Prime Protocol. What I will go ahead and actually show a very quick demo of this. So let me drop off, or let me switch my screen here. Cool. Okay, got it. So Prime Protocol is actually a DeFi prime brokerage. And they are live in production. In previous presentations, I was demonstrating their testnet on Moonbase Alpha and interacting with other networks there. It's 100% live. So this is production, which is really, really cool. And let me tell you a little bit about Prime Protocol and how it works. So a prime brokerage is essentially for a bank with its VIP clients. You can deposit a bunch of different assets with the bank, and you have relationships with the bank in a number of different ways. So you may have stocks and bonds. You may have a home mortgage. You may have a car. You may have all these different things that the bank is helping you manage. And in a similar sense, with Prime Protocol, you can deposit lots of different assets here into their lending and borrowing protocol. Prime is multi-chain in the truest sense of the word. So you can have assets across many different chains, and you deposit them on their original native chain. So there's no bridging, there's no switching networks, and then bridging over wraps tokens. Instead, you keep the original assets on the original chain that they're on, and Axelar's Prime's satellite smart contracts. It does use Axelar, but Prime's satellite smart contracts will recognize your deposits, and then they'll credit you. So let me start from an example from kind of the beginning. Let's say that I'd like to take out a loan of USDC, and I'd like to deposit some of my Glimmer on Moonbeam. So I can do just that. I've deposited here 10 Glimmer on Moonbeam. And so my total number of deposits here is recognized, and you can feel free to deposit more. And then I can go ahead and borrow on any supported network through Prime. And in this case, I've borrowed 50 cents of USDC on Avalanche. Now, this is a major deal. Prime can recognize your deposits across many different chains, and you can borrow across many different chains. And think of this as like a central nervous system or a central heartbeat, where this is a simple example, right? Where you deposit on one chain and you borrow on another. But you can actually have a pretty complex set that you could have a variety of different assets that you're lending and borrowing at the same time. And of course, Prime will take care of managing your liquidation risk and managing all that, warning you if you get too close and things like that. So how does this work in terms of its decision making and things like that? Well, again, the brains of the smart contract exist on Moonbeam. That includes things like risk in terms of how much can you borrow. That also includes things like directing liquidation decisions. So those decisions originate from Moonbeam, and then the satellite smart contracts, which is where you deposit your collateral on these other chains, would then receive a message from Moonbeam that says, hey, if necessary, it would receive a message explaining that it needed to make a partial or a complete liquidation. So let me head back to the presentation here. And we also have a couple more demos coming up. Cool. Okay, so I gave a quick demo. Feel free to try it out yourself. It is 100% live on production today, which is really, really cool to see. And there'll be many more applications that use a similar type of approach. Prime is leading the way. They're pioneers in this new approach to building applications, and they are a phenomenal example. Colton is amazing. Colton, the founder of Prime Protocol. So being conscious of time, I do want to speed things up just a tad. So let's speed through just a little bit. Okay, so speaking of benefits, at the end of the day, right, why is Moonbeam so interested in connected contracts? At the end of the day, we want to help provide better experiences for users. We want users to feel impressed with their Web3 applications, and we want to build applications that have wonderful user experiences that, of course, can cater to both crypto OGs as well as newcomers. If we're going to bring in, the next million or billion people into Web3, we need to have interfaces that cater to them in terms of being easy to use and easy to understand. So, of course, there are additional benefits to having a connected contracts approach. And one is this sort of fragmentation issue, where if you have a DeFi application, you don't want to just segment all of your users across many different chains. And why don't you want to do that, right? Why, say you have $10 million of liquidity, what's wrong with just putting $1 million of liquidity on each chain that you're deployed to? Well, as any DeFi degen can tell you, you're going to get worse prices when you have lower liquidity. So all of your trades are going to be priced less efficiently, and it's just going to be a less pleasant experience. Versus if you're able to tap into a multi-chain liquidity approach where you're not separating your liquidity across a bunch of different chains, but instead it's concentrated or accessible from different places. Whereas you could be on any chain and access liquidity. That is a big, big deal. And of course, also, you have the ability to be more efficient because each chain can specialize in what it does best. So if your chain specializes in privacy, you don't need to bring a separate privacy solution to your chain. Instead, you can go and access it where it already exists. Let the privacy people specialize in the privacy and just access and tap into that functionality. And finally, all of this is meant to improve the end user experience at the end of the day, hide the infrastructural complexity that multi-chain applications They add a little bit of complexity to the developer experience for sure, but at the end of the day, they can provide an experience that is much, much better. And it's not just a simple like incremental 10% improvement. This is something that's a huge, huge, huge exponential level improvement. It's absolutely, absolutely tremendous. So let's look a little bit. I want to compare theory to kind of real life and real world usage real quick. So for a normal single chain application, here's kind of a diagram of what it looks like in theory. So the user connects their MetaMask. The application checks to see if it's the right network. If it's not, you'll get a pop-up saying, hey, please switch your network. And after that, hang on, let's back up a second. It checks to make sure that you have the network added in your wallet, right? If you don't, MetaMask will typically pop up and say, hey, would you like to add this? Would you like to add this network? And it'll tell you, you can approve or deny. So let's say you already have the network, then you'll be presented with the transaction. And if you agree to the transaction, if you want to approve it, you can go ahead and press approve. And then the wallet will share that signed transaction object with the network through an RPC provider. And then a node will receive that. It will get processed. It'll get included in a block. And the front end of the application will be listening and looking to see, typically through an event, but it'll be looking and checking to see whether that transaction has gone through. And then it'll update. Cool. So this is relatively straightforward. This is the approach that everybody knows. And this has been around for, call it 6 or 7 years. It's been around for a while. This is theory. And as I'm sure many of you are aware, real life can be different than theory. And so what's the real life single chain experience? It tends to look something like this. Constant pop-ups asking you to change your network, asking you to add a new network, asking you to do all this. It gets exhausting, right? And this is for a crypto OG is still going to be exhausted from this. Imagine a newcomer, right? And a newcomer has all these prompts to switch their network, and then it's asking them to add a new network, and then it says that the network that they're adding, they've never added it before, and make sure they know what they're doing, and this can be scary and intimidating. What if there was a different approach where all they had to do was confirm just one transaction, such as the one on the left? They probably not even prompted to switch networks. They're probably already on Moonbeam, and they can use Moonbeam as their home base. They can have one gas token. They can have Glimmer. They don't need to go out and bridge. They don't need to go out and switch networks or get a new gas token. They can pay for the transaction that they're going to take on the destination chain. They can pay for that right on Moonbeam. And so when we think about the life cycle of a transaction here, the user confirms a transaction here on Moonbeam. That transaction gets confirmed, and it will interact with a GMP provider. And the GMP provider will relay that transaction to the destination chain on their behalf. So as is typical, the user pays for gas on the origin chain. So they pay for the origin transaction, and then they pay a little bit more in order to cover the gas fee of the destination transaction. And so, of course, this varies. So if your destination is Ethereum, you're going to pay more. If your destination is another chain, perhaps you won't have to pay as much as Ethereum. But the key thing here is that the user doesn't have to worry. the user can access features and functionality on many different chains and not even know, they may not even care which is the ultimate chain where this interaction is taking place. If you're buying an NFT, if you're making a swap, if you are, let's say, accessing a specific, equipable NFT or anything like that, they may not care about the ultimate, destination of that transaction. They care that the interaction is fluid and works and is quick and seamless, and so all of that is enabled here. So one more quick demo. I want to show you exactly what it would be like to send a message from chain to chain. So let me go ahead and share my screen here. Cool. We'll go back to this other page here. I think it just takes a minute to pop up. Cool. So back on Prime, let's navigate over to this multi-chain demo. And I want to zoom in so that everybody can see. Cool. So this is a simple application for showing you what it's like to send a message cross-chain. And of course, you can send any message that you want. You can say, we can just say hello. But typically, you're not going to be saying hello. Typically, you're going to be sending along a contract call. That's most typical. And another thing to point out here is that I think bridging was kind of the earliest, entree to general message passing protocols. And it's important to think of bridging tokens as just one use case or just one application of general message passing. Bridging funds is not the only application, but it's just one thing that you can do. And there's really a lot more that you can do once you kind of think about it in a general message sense, right? So let's try to send a message. So hello, Bear Necessities Hackathon. I think I had a typo. There we go. Necessities. You can choose from many different GMP providers here. In this case, we'll choose the first one here, that's Axelar. But I encourage you to experiment with all of the different GMP providers here. We're going to be sending this message from Moonbase Alpha, and you can choose a couple different dropdowns. We're going to send it from Moonbase Alpha, and we're going to send it to Avalanche. Let's make sure our MetaMask is connected. And again, all this is testnet. So we're just sharing, we're just spending testnet funds here. That's all. So let's go ahead and press submit. When I confirm the transaction, I'm going to be asked to send along a token value with it. So in this case, I'm sending along about just under 2 dev. The comparison between testnet funds and real world funds is not one-to-one or anywhere close. What I mean is it's not going to cost you, you don't want to look at the testnet values, and if you get some value like, oh no, it costs 20 dev or something to send a message, that is not directly comparable to a production network. And the reason for this is because testnets are very separate and all different in their design and their supply. And also because they're testnets, it's impossible to do a gas equivalency between the two networks and figure that out. Whereas in the real world, on a mainnet, if you're looking for a specific target, or you may, it's easier to make these cross-chain comparisons in terms of the payment of gas. So a couple things we can look at. So we have the transaction hash for the transaction on Moonbase Alpha. And we can actually go and look this up on Axelar Scan. And we want to look up actually the testnet of Axelar Scan. So let's go ahead and open that up. We'll paste the transaction hash here. Cool. And we can see that the method is we are calling a contract, we can see the status of where the transaction is taking place. It is a multi-step process, right? So the transaction on Moonbeam, the origin chain, was successful. You can click on here and you can look at that to see more if you'd like. And we can see that it's in the process of getting executed on Avalanche. It isn't done yet, but we should see that come through shortly. As a fun, quick little thing here, cool. We can see cool. So when we say confirmed here, we know that this was confirmed by the Axelar network. What does that mean? So Axelar is a decentralized network. They have a bunch of different validators, and they do need to come to approval to allow you to execute your cross-chain call. So that's what the confirm step means here, is that Axelar has validated your transaction. They've said, okay, and then they've dispatched it here to Avalanche. And so if we go and look at this transaction hash, we can see that it was successful. And we can also do something different, which is we can view, we can see approved contract call, and we can see a couple different things in here, but we can see the origin of Moonbeam, and we should also be able to see, it may be more visible in the origin chain transaction here. So if you look on Moonbeam, if you go to view input, we can see hello Bear Necessities. We can see the destination contract address and the destination network. So if we go and look at the address here, we can see that that matches. Cool. So that was a quick multi-chain demo. There is a lot more that I want to cover, so I want to jump back quickly to the presentation. Feel free to jump in the chat if there's any questions. Cool. So we mentioned bridging tokens is just one application of things that you can do with general message passing. We have tons of different resources here for interacting with GMP providers and for getting started in a simple way. So don't be intimidated. There is some nuance to building, but there are ways here. You can start with the demo that we just showed. Then you can move on to a blog post here, which I highly recommend. So we have examples such as this one, which you'll essentially recreate the application that we just built, right? Minus the UI, but you'll build the contracts that take care of that exactly. And it's really fun when you do this yourself. And of course, you learn quite a lot by doing that. And then you can progress on to using the Axelar SDK. That helps you do things like estimate gas. That helps you do things like build your transaction and much more. And then you can progress, and as you get more advanced, you can move on to designing a multi-chain application in a sense of how do you actually design your UI? How do you build something that's friendly to users? And so Jeremy goes into detail here, showing exactly how you can do that. I'm not going to go through all of these examples here because there are kind of too many to talk about right now. But the reason I put these here is because there are so many resources out there. It can be kind of like, well, hey, where do I start? We're going to share the link to these slides, of course. I'll share them in the Moonbeam Discord. And these will be available afterwards, so you can check them out. For each GMP provider, I wanted to show the link for how to do things consistently. And so I think one of the big ones is how do you send a message? Then it would be what are the contract addresses for each GMP provider? And so all that is here for each, for Axelar, for Hyperlane, for Layer 0, and Wormhole. So we still have one huge topic to cover, and that is precompiles. So in the Bear Necessities Hackathon, the Moonbeam Foundation has a couple different major bounties. And um, the first two are the grand prizes. And these are very open ended, can be any type of project that you want to build. And there are two major prizes. So they're $7,500 each, and they're going to be evaluated on 4 different categories. So they're going to be evaluated on technical excellence, user experience, value proposition, and of course, creativity. So if you're building something that's pertaining to connected contracts, this is kind of where you are going to fit in and where you're probably going to be looking to apply to that particular bounty. But we also have the best use of a Moonbeam precompile. Moonbeam has a ton of precompiles. And before we talk about all of them, we of course need to mention, hey, what the heck is a precompile anyways? So precompile is a fancy name, but what it represents is actually something quite intuitive and quite cool. So Moonbeam is built with Substrate, right? And Substrate is extremely powerful. It allows you to do things with blockchains that you wouldn't otherwise be able to do. And at Moonbeam, we provide a way to access some of this Substrate functionality via precompiles. And a precompile is just a Solidity interface. It has an address that's predefined. And whenever you call a function at this particular predefined precompile address, it actually short circuits, essentially. It takes a shortcut, and it's not actually executing Solidity code at that point, but once you call the function, it actually calls directly into Moonbeam's runtime, where it can execute this specific Substrate functionality. Now, we have lots of different features that are available in and through our precompiles, and this includes ones like staking, democracy, and much more. So I can go through a couple of those actually. For the staking one, I'm going to give a complete demo, and so I will do that right now. So let's go ahead and take a quick look at the staking precompile. Again, the precompile is just a Solidity interface that allows you to access features that you wouldn't normally be able to access. So let me go ahead and do that. There we go. Okay, cool. So I have here the staking interface.sol, and this is the precompile. So let me zoom in just a tad. Oops, that might have been too much. In any case, we make sure that we always have the address of the precompile at the top, so that you know exactly what it is that you need to, you know, the exact address that you need to interact with. We have a bunch of different functions for each precompile. In the case of the staking one, of course, we have all these functions that pertain to staking. We have read functions, we have write functions, we have some deprecated ones too occasionally as these palettes get updated and revised. And typically, as new features get added, for example, as auto compounding came to staking, that too came to the staking precompile. So the process here is you access the staking precompile. You can copy it into Remix, and let's go ahead and compile it. Let's copy the address here. Let's change our environment to injected provider MetaMask and make sure that the network is in your wallet is on the network they'd like to interact with. So in this case, that's Moonbase Alpha. Remember that this is a precompile, so we're not actually going to be deploying anything. This is already deployed and it's already accessible. So all we're going to do is paste in the address of the precompile, and we're going to press @address. Now, common mistake here is that you may forget to change your environment. If you forget to do that, you're going to have an error. So just make sure that you're using injected provider MetaMask. And let's just expand this window just a tad. And so I'd like to actually stake in this case. I'd like to use the delegate function. And the delegate function takes a couple different parameters. It takes the address of a collator, it takes an amount, and it also takes a candidate delegation count and a delegator delegation count. Now, these are not critical fields for the actual staking operation. This is rather used to determine the appropriate weight of the call. And so we can provide an estimate here that's well over what we need. And the transaction will go through just fine. Now, one of the things that you may not know exactly when you just start out with this is, hey, what are the decimal points and what are the parameters like the minimum delegation amount? So we, of course, have that here. We have a read function that you can call. And we can see that the minimum delegation amount is 1 dev, which has 18 zeros. So dev is the Moonbase Alpha testnet token. I have plenty of dev here. And so let's say that I'd like to delegate 4 dev tokens. So I do need to pick out a collator that I'd like to delegate to. And so we can head to apps.moonbeam.network. And this is also helpful because you can see right now I have 0 delegations. So this is proving that, that we have nothing staked right now at the moment. So let's go ahead and pick a collator. You can copy the address by clicking on the circle icon. And let's head back to Remix, and we'll paste our candidate address. As I mentioned here for the candidate delegation count, this is referring to how many other delegators are delegated to this particular collator. Now, we don't actually care what the specific value is. We just need one that's large enough. And so the maximum is 300. We can just put that. And in terms of delegator, this is how many delegations do you already have from your own account. We saw I had none. But again, we can just put a value here that's relatively large to make sure that the weight of our call here is sufficient. So all we're going to do is delegate for dev to this particular collator candidate. Let's go ahead and press transact. And I will confirm the transaction in MetaMask. So the staking precompile is just one particular example. There are several different precompiles that allow you to do very cool and very powerful things. So that was successful. And just to prove it, let's head back. And we can see our delegation is already reflected here within apps.moonbeam.network. So apps.moonbeam.network actually uses the staking precompile, and there are other applications that use the staking precompile as well. But you can see how easy this was, and it was very quick, it was very efficient, and it was fantastic. So let me change really quickly back to the slides. I hope people aren't getting seasick here saying, hey, stop changing between the slides. In addition to the staking precompile, there is a conviction voting precompile. And Moonbeam has a huge focus on governance. And we have many different ways for you to vote, right? One of them is you can go to Polkadot.js apps, and you can go and you can vote there. But that's kind of that's a clunky experience. And so solutions like PokeAssembly provide a beautiful UI for you to interact with governance and vote. And that's enabled by the conviction voting precompile. And so in this quick demo here, you can see in this quick GIF that Alberto produced, you can have the ability to set your voting balance. You can set how long you'd like to lock your tokens for. You choose all the parameters that you want in the UI. And if we go and look at this precompile, you can see that the exact structure of the vote will be set up. And there are different ways you can break down a vote. And there are also some things that you might want to do after the vote. You may want to review vote locks, and you can take care of that through the conviction voting precompile as well. There's also an ERC20 precompile, which allows you to interact with the native token of Glimmer, or Mover on Moonriver, or Dev on Moonbase Alpha. You can interact with the native token as if it were an ERC20. That's called the native token precompile, or the ERC20 precompile. We also have a batch precompile. You can combine many different transactions to take place in a structured way. You can say, hey, we want all of these to succeed or nothing, or we want you to try each transaction until one fails and then stop, or we want you to just try to execute as many as you can. It's okay if some fails. So you decide the structure, and you can do clever things, such as if you have a DEX and you want to make a swap, there's no need for a user to make an approval if the swap doesn't go through, right? So you can have an approval and a swap, and you can say either both of them go through successfully or none of them go through, which makes a lot of sense. And not just for security purposes, but also for convenience and usability purposes. This is something where it's much better for your user. And we have other ones as well. So coming to the end, Christopher asked a question. This general message passing, is it being used in the medical field as of yet? This is a fantastic question. I don't know yet of use cases that are particular to medical. I'm sure that there are use cases for sure. Yeah, it just hasn't crossed my radar just yet. And the medical field might be a bit slower, maybe to they might start, with maybe an internal blockchain, maybe a private validator set where they can have data that's stored, and maybe the collators of their particular blockchain, perhaps they have to be HIPAA compliant or something like that. That's something that Polkadot could certainly allow them to do, because they could have a whitelisted validator set. And I think that would kind of have to be a precursor before they then moved on to things like general message passing. Yeah, but certainly possible. So thank you so much for your question, Christopher. I appreciate it. So you saw, I think we touched on these prizes here, but I did want to call your attention to registering for the Bear Necessities Hackathon, which you can do so at moonbeam.hackerearth.com. If you're not sure if you want to participate, go ahead and register anyway. You'll get event updates, and you'll get reminders, which I highly recommend. Even if you don't have time this week, maybe you want to start next week. You still have some time. So visit us in the Discord at discord.gg/moonbeam. There is a hackathons channel. We have tons of channels in Discord, but we're going to be looking in particular at the hackathons channel. So that's kind of the fastest place to get a question answered. Thank you so much, Christian. I appreciate your kind words, and I appreciate everybody for showing up here. And we hope to see you around in future workshops. We have 2 more that are taking place this week. Tomorrow we have Bioeconomy, and Thursday we have Stella Swap. So please join us for those, and thank you so much for joining us today. Thank you, everyone.